Hi everyone, welcome back to Hershey Learn. In the last few videos, we learned what is stack and heap and what are value types and reference type. Now, let me ask you a simple question. If we have a normal value like int, can it behave like an object? And if yes, what happens inside that memory? Does it stay in stack or does it move somewhere else? And can we get it back again? You'll be having these kind of questions in your mind, right? But don't worry, it's actually very simple. Okay, and today we're going to understand this clearly using boxing and unboxing in .NET. Now, before we go deeper into boxing and unboxing, let's quickly connect this with what we already know. Okay, we have already seen that value types are stored in the stack and reference types are stored in the heap. So normally things are very clear and simple. But in real application, sometimes this boundary doesn't stay the same. Okay, the a value type which usually stays in stack can actually be treated like an object. And when that happens, it moves from stack to heap and behaves like a reference type. That's where boxing comes in. Okay. And when we want that value back again, it moves from heap to stack and that's called unboxing. So this concept is really about how data moves between stack and heap and how that affects memory and performance. And once you understand this, you will clearly know what's happening behind the scenes in .NET. Now, let's understand boxing in a simple way. We start with a normal value like an int, okay, which is usually stored in the stack, and that's how value types usually behave. Now, when we assign this value to an object, it can't stay in the stack anymore. So, what .NET does is it creates a new copy in the heap and copies that value into it. And at this point, the value is no longer just a simple value. It is now treated as a reference type. So, what's happening here is it's a very straightforward. First, the value is converted, then it moves from stack to heap, and finally, new object is created to hold that value. Okay. And one important thing to remember here is the original value in the stack is still there. That means boxing doesn't move the value. It actually creates a copy of it in the heap. Now, why should we care about this? Because boxing uses extra memory and also involves additional processing. And if this happens frequently, especially inside loops, it can impact performance also. Okay, so in simple terms, you can think of boxing like a value type that is converted into an object and stored in the heap. Okay, that is boxing. Now, let's see how boxing actually works step by step. First, we start by creating a value type. Okay, here we have int a is equal to 10 and this value is stored in the stack just like any normal value type. Okay, next we assign this value to an object. Here, when we do object obj is equal to a, boxing happens. At this moment, .NET creates a new object in the heap and copies the value a, that is 10, from stack into the heap. Okay, so now we have two things here. The original value a is still in the stack and new object is created in the heap with the same value. Okay. And finally, the variable obj doesn't store the value directly. It actually holds a reference to the object in the heap. So now obj is pointing to the value that is stored in the heap, not the stack. Okay. And the important thing to remember here is boxing doesn't change the original value. It simply creates a new object in the heap and copies the value into it. Okay. So in simple terms, what's happening here is value starts in stack and gets copied into heap and the object holds a reference to it. Okay. And that's how boxing works in action. Now let's understand the opposite of boxing, which is unboxing. So earlier we saw how values moves from stack to heap. Now the question is, how do we bring that value back? That's what unboxing does. Unboxing is simply a process of converting reference type back into a value types. So let's break it down step by step. First we have an object in the heap. This object is holding some value. Okay. Next we explicitly tell .NET that I want a original value back. So .NET takes that value out of the object and finally places it back into the stack as the value type. So, in simple terms, boxing means value goes to the heap, unboxing means values come back to stack. Okay, and one important thing to remember here is unboxing always needs an explicit casting. Okay, and we'll clearly see this with a code example in the next slide. All right, let's see unboxing in action. So, here we have a simple example. First, we create an object like this. Object obj is equal to 10. Okay, now what's happening here? Even though 10 is a value type, it is stored inside an object, which means it is now sitting in the heap. Okay, so far this is unboxing, which we already understood. Now comes the interesting part. We want that value back again as a normal integer. Okay, so what do? We explicitly cast it like this. Int a is equal to, in the bracket we need to keep this integer and object. Okay, at this moment unboxing happens. So what exactly happening behind the scenes? First, .NET goes to the heap and finds the object. Okay, then it extracts the value. In this case, it is 10. Okay, after that, it places that value back into the stack as a normal value type. So now a is just a regular integer value. Okay, so simple, right? But there is one important thing you should always remember. That is, unboxing requires an explicit casting. Okay, not just that, the type must match exactly. Okay. If the type doesn't match, your program will throw an exception at runtime. So you always need to be careful when doing unboxing. Okay. If I say it in simple lines, values come from the heap and extract the value using casting and stored back into the stack as a value type. Okay. That's how unboxing works in action. Alright, now let's talk about something very important. Till now, boxing and unboxing look simple, right? But here is the reality. They come with a cost. Let's understand what the cost is. Okay. First is memory usage. Whenever boxing happens, .NET creates new object in the heap. That means extra memory is used. Okay. And not just that, more object in the heap means more work for garbage collector. So over time, this can increase memory pressure. Okay. Next is copy overhead. Every time you do boxing, data is copied from stack to heap, and during unboxing, it is copied back from heap to stack. So there is always back and forth movement happening. Okay, and copying data is not free, it takes time. Now, the third one is runtime cost. Both boxing and unboxing add some extra CPU work. It may look like a small thing, but if this happens again and again, like inside loops or frequently running code, it can slow down your application. Okay. So, what's the takeaway? Boxing and unboxing are useful, but don't use them too much. Okay. Try to avoid them in performance critical code. Instead, use generic or better type design whenever possible. So, in simple terms, when boxing happens more, we use more memory. When data keeps moving back and forth, things become slower. And when all these operations keep happening, the CPU has to do more work. So, overall, the application performance can go down. And that's why understanding this really helps us to write better and faster code in .NET. Okay. All right, let's quickly recap everything that we have learned. Okay, first, boxing. Boxing means a value moves from stack to heap. That means it gets converted into an object and stored in heap memory. And second, unboxing. Unboxing brings that value back. That means it takes a value from heap object and it places it back into the stack as a value type. Okay, now here is the important part. These operations are useful, but they are not free. Okay, every time boxing happens, a new object is created in memory, and every time unboxing happens, the value is copied back. So there is a extra memory usage and extra work is happening behind the scenes. So if this happens again and again, especially inside loops or frequently running code, it can make your program slower. Okay. So what should you do? Try avoid using boxing and unboxing unnecessarily. Okay. Instead, use things like generics and proper types. This helps your code run faster and use less memory. So just remember the simple idea. Boxing and unboxing are helpful, but use them only when it is really needed. Okay. Alright, that's it for today. We understood what boxing and unboxing are and how data moves between stack and heap. Just remember, they're useful, but use them only when it is needed. Okay. If you found this helpful, please like the video and subscribe to my channel. Your support really motivates me to make more videos like this. Okay. Thank you so much. I'll see you in the next one. Until then, keep learning and have a great day.